All right, hey everybody, I am back in my classroom trying to explain how we would do the egg bungee drop challenge were we in class, but of course we're not in class, so this is the next best thing. And what we would have you do is design a device with materials we would give you. We would give you yarn and straw and cups and rubber bands and nylon stockings and things like that that you could use to protect an egg if you were to drop it. And I'll use a golf ball today since I didn't bring eggs to class today. Golf ball's the next best thing. So here's a cup, for example, and there's some cotton in there, and there's a long stretchy piece of yarn that's attached to this. And this would hang from a force sensor that looks like this. It's just basically a hook that will read how much force is being activated on it when you pull on it, and it goes off and it talks to a lab pro, like the one we used for the smart pulleys in the Newton's second law lab. And then instead of talking to a calculator, it would be talking to my laptop. All right, so that is the force sensor hanging from the light fixture behind my desk. And it is connected by its wire to the Lab Pro here, okay? And so it's talking to the Lab Pro, and then the Lab Pro talks to my laptop. And there's a graph that I made a little bit earlier, and we'll explain that in a bit. So that's the chain of equipment: force sensor to Lab Pro to laptop. And if we produced graphs like this for you guys, we could have printed them out, and then you would go off and analyze them. So that's the basic setup. Now I wanted to show you visually what a couple of these bungees look like. So this is bungee number one, and it's, again, the yarn and the cotton. Now, yarn is a little bit stretchy, but it's not super stretchy. And so you can see what this might look like if I were to drop it from a height of about 7 feet. So here we go. Okay, let's do it one more time so you can see it. It's happening pretty fast. It may even be able to hear kind of a thunk when it lands. Okay, so that's bungee number one, and we will give you the data for that somewhere else. Bungee number two is I'm using a nylon stocking and some rubber bands and just a hook on the end to attach to the force sensor. Same golf ball in there. This one might look a little different. Okay. One more time. Okay. So that data will also be provided to you for each of those jumps. And it'll be interesting to compare them because they might look sort of the same in the video, but they're very different when you break it down and analyze the forces and the times involved, which we'll be able to do elsewhere in the course of doing this activity.
Okay, so actually we do not have to wait for some other video for me to share the data with you. I'm able to put it here into this video. So we're going to very quickly compare and contrast the graphs from those two bungees, bungee number one and bungee number two. Here is the graph from bungee number one, which was the cup and the yarn. And so let's see what we're looking at here. We have a y-axis of force and an x-axis of time. You can see the y-axis goes up to about 20 newtons here. The x-axis goes out to about 4 seconds. And you can see here that a little after 1 second, there's this big spike in force. And then there's a couple of other spikes because it wasn't just one bounce. It went bump, bump, bump. It was a couple, 3 events. But we're going to focus primarily on the first bounce because that's where the majority of the force would occur, obviously. And so here is the maximum. At about 1.24 seconds, we got a spike of 16.73 newtons here at the peak. And this is happening, this spike occurs in a relatively short period of time, maybe about 1/10 of a second. So that's the first bungee. The second bungee was the stocking and the rubber bands. See if you notice some differences here. This force axis, the y-axis, only goes up to about 3 newtons. Time axis is about the same. And again, right around 1 second, we get a spike, but this spike lasts maybe 0.7, 0.8, about 3/4 of a second, as opposed to 1/10 of a second. And so its maximum is significantly smaller. It's around 1.78 newtons here at this peak. And again, you see more than one event because it goes bounce, bounce, bounce. But that is a very different looking graph, both in terms of the magnitude of the force and the time that over which it took place. So there's the data. And now we'll head back to my classroom to wrap this all up.
All right, so that's all I wanted to show you today. Hope that makes sense. See you soon.